all back to my channel INFOtainment. Let us learn the DFT of few other signals which are usually asked in the PTU examination of digital signal processing. Now that we have learned the DFT of e raised to the power minus j 2 pi k naught n by capital N and e raised to the power plus j 2 pi k naught n by capital N, let us see the DFT of cos 2 pi k naught n by capital N and sin 2 pi k naught n by capital N. Now, first let us take cos 2 pi k naught small n by capital N, which I can write it as e raised to the power j 2 pi k naught small n over capital N plus e raised to the power minus j 2 pi k naught small n divided by capital N whole divided by 2. Okay, so this would be cos of 2 pi k naught n by capital N. Now, if I find the DFT of this, I apply this or I use this in my normal formulae of DFT, that is x of k is equal to summation n varied from 0 to n minus 1, and this will be x of n, so I just substitute as it is half into e raised to the power j 2 pi k naught n divided by capital N plus e raised to the power minus j 2 pi k naught n divided by capital N into e raised to the power minus j 2 pi k small n divided by capital N. This is the one where this part is in the DFT formula, whereas this entire part will be x of n. Now, how do I solve this? Is very simple. I just group it, summation n varied from 0 to capital N minus 1 half into e raised to the power j 2 pi, I just multiply this inside, 2 pi into k minus k naught, I read the minus sign outside, small n divided by capital N. So what did I do here? I took the common factor in the powers of this. So here you can see j 2 pi n are common, j 2 pi and n are common, so I've written it outside, k naught, and here you have minus k left, so I've taken minus outside, so therefore it becomes k and minus k naught. So when I multiply inside, I get the product of these two back. Now on the same lines, I just take the common factor in the powers of these two terms, e raised to the power minus j 2 pi into, here minus is there on 2 in both the terms, hence I can directly take it as k plus k naught into n divided by capital N. Now I just split it, that is equal to half into summation n varied from 0 to capital N minus 1 e raised to the power minus j 2 pi into k minus k naught into n divided by capital N plus this half will be for both the terms into summation n varied from 0 to capital N minus 1 e raised to the power minus j 2 pi into k plus k naught into small n divided by capital N. Now, the solution of finding the DFT of this term as well as this term is as shown in the previous video, which I will be putting in the I button above. So if you haven't watched it, you can visit it and watch how to find the DFT of this term separately and this term separately. So in this case, I would be directly writing the expression. So in the when you find the DFT of this, you would be getting half into n into del of k minus k naught plus n into del of k plus k naught. Fine. So this is how you find the DFT of this sequence. If you wish to find the actual procedure in between, like how exactly I find the DFT of this, how exactly I compute the summation of this from 0 to capital N minus 1, then you can visit my previous video, which will be available in the I button above, so that you can see how I compute the DFT of this term separately and this term separately. Fine. Now that we have found out what is the DFT of e raised to the power j2 pi k naught small n by capital N, that is half into n into del of k minus k naught plus n into del of k plus k naught. Now let us try to find the DFT of sin 2 pi k naught n by capital N. In this case, there are slight changes in the formula which I will be showing you. Here e plus becomes e minus, so sin becomes cos, sin 2 pi k naught small n by capital N will be e raised to the power j2 pi k naught small n by capital N minus e raised to the power minus j2 pi k naught small n by capital N into 1 by 2j. Okay, so this minus sign will be everywhere, so I just have minus, minus, minus over here and minus over here, and as you can see here I have 2j, so I'll just write 2j in the denominator. That's all. There is not much of difference when I compute the DFT of cos 2 pi k naught n by capital N and sin 2 pi k naught n by capital N. Just this plus in the case of cos becomes minus. Here j will not be there in the case of cos, but here you get j in the case of sin. That's all. So the DFT of sin 2 pi k naught n by capital N would be 1 by 2j into n into del of k minus k naught minus n into del of k plus k naught.